Welcome to CTO Think, a podcast about leadership, product development, and tech decisions between two recovering chief technology officers. Here are your hosts, Don Vandemark and Randy Burgess.
Hey, Don, what's going on?
Well, as we're recording this podcast, as I'm sitting at a Tesla charging station, I'm on my way north to Atlanta to visit with some potential clients and some existing ones for construction specialties. So, bit of a selling week this week. We did a little bit of this last week as well. Had a good contact. That's not real CTO talk, but that's what that's what I'm doing this week anyway. So, what about you?
Planning. What I probably last time we talked, I probably said the same thing. I'm part of a big project at work, and I'm in the role of, I guess, helping architect different services. So, because I'm a part of a team that does service-oriented architecture. So, pretty much it's plan, a lot more than I'm used to. Because usually, I was telling someone today, usually I create a card. It has a subject that says build this, and then I start building it with a few bullet points. And since I have to write it up for other people, I have to do a lot more detail. Feels a lot more waterfall. Someone called it waterfall and got yelled at. so that tells me it's waterfall. But yeah, so that's what I've been doing.
Well, I think that's a good thing to talk about today. Is I've been at IB. I mean, the term service-oriented architecture has been around for a while.
Yeah.
And I never really grasped onto what the nebulous term means. So what's your understanding of it?
So what I'll call it, it's the idea of taking processes or functions or features in what is a monolith application and breaking it out so that the best way I'll term it is it becomes part of a request-oriented architecture or a request-oriented process. So let me give you an example. When I first started building Rails apps, each app would need to communicate by sending out emails. It could be as simple as sending an email to change a password, sending out a transactional email to remind someone of something they needed to do, an email to confirm that an action they took was done, that kind of thing. And in our code, which was like a single threaded in the sense that, hey, we've got a CPU on the server, and when a user clicks on an action and the side effect is to send an email, that's all part of that same CPU cycle. And in theory, if there's only one process thread, the time it takes to send that email and get a confirmation back from the email service, it could possibly block other requests from being done. So in theory, you could be asking, hey, I want to see the homepage for this app, but the app could be talking to MailChimp or talking to Constant Contact or something, and it would say, hold on, I've got to do that email, and I got to handle this email process. You have to wait on this homepage. Now, usually that is a very fast process, but once you start to build up all those email requests and homepage requests, you start to find yourself in a position where this process talking to this external server may be eating up cycles that you need to use for loading web pages. So how do you get around that? Well, the most common way in Rails is to set up a queue. You have something like a Redis server or a REST queue or something, You set up a queue, and instead of your application making a live request to an email server, it simply does a really quick action of, here's a request I need to send out to email, put it into a queue, and then let a different process or a different CPU or worker in this case grab those messages and do the work for you on the side on a completely different thread. So now you are no longer using the time back and forth on the request to send the email as part of the web loading cycle as well. You're saying, I need an email service to just take over and send out these emails. So that's the first example of breaking out a monolithic app into a service. That's my best explanation. Does that make sense? Is that what you know it to be?
So it's really no different than what we've been doing for a long time, and that's just putting various services together to create a system. Is that a good generalization?
Yeah, but I think what happens over time is you start to build, instead of having a monolith that does a ton, like 90% of your work, and then you start to break out little services, you start to build an architecture where 90% of it are various services talking to each other.
Right.
But that becomes, as you break it out, each one becomes its own fiefdom, its own little castle, its own, hey, I get requests, I process things, I send out other requests. And because of the way that these services need to communicate, and because some services get burdened with more requests than others, you have to build in a message queuing system that allows these services to talk to each other. You're no longer going to have one main app talking to multiple services. You're going to have services working in conjunction with services. It becomes a completely asynchronous world. That's what your app is becoming as you push towards the service-oriented architecture. But you are also creating more work in the sense of your service, you're providing the service on the left hand, and then on the right wing, you got another one, and their changes may not be in sync. So you always have to create, you're basically creating these little stacks of applications that are in their own world, require their own complete start to finish build process, deployment, testing, what have you. And that you would think, hey, that isolates it from changes elsewhere, but in many ways it doesn't. It's like, hey, you may be changing things on this one service, but you've got 4 depending on you. Now you got to coordinate with them.
Right.
If all of a sudden a new service comes online and starts inundating the email service, and the email service wasn't ready, now you got to focus on the load that the email service is handling. But the other side of that is, if all of a sudden you're burdening the email service with more work, you can isolate your cost structure to deal with, okay, well, email needs a few more CPUs. I need to have more workers just for email. I don't have to pay for workers, because like right now on a monolithic Rails app that needs more memory, if one part of the Rails app needs that memory, I have to pay for it so everyone's got it. So all the different features and certain parts of the application, I can't just say, oh, I just need a fraction of memory for this one little piece. I basically have to tell my host or the server, like, I need a bigger allocation of memory for just this one little piece, instead of breaking it out and saying, oh, you know what, I can just queue this stuff up and it can run on its own. And that's a lot cheaper. So in a way, you have the complexity of isolating users in their own worlds, but in some ways, you are empowered to contain costs and focus on those worlds. There's always
Right.
there's a balance there you're dealing with. Some of it's good, some of it's bad, I think.
So I wonder, and I could be oversimplifying it or just completely misstating it, but I wonder if the message queue is really the defining feature of service-oriented architecture, because it's what's holding everything in place to say, yeah, go hit this thing now, or go do this thing now. Go deal with this service at this point. Is that
Well,
a fair statement or not really?
I think it's one way that people approach it. I don't know that everyone
Okay.
does it that way. Like, I think it's wise. I think having a queue for requests is much more resilient than just putting out API endpoints and saying, handle the load as you get it. Because I do know that some companies have approached SOA where they just say, hey, here's a service that has an endpoint for requests, and we'll handle any kind of staging of work on our back end. But I think, like, here's a good example of why a queue is great. If you were to send a message out by Twilio, you and I worked on this with our chat SMS project. And if you track the status of a message, there are like 8 or 9 different updates you get, from request to queue to sent to delivered to failed to, like, there's all these different status updates that Twilio can make a callback on for you to know, did that message go out? Where is it in the process? That's 8 different requests that come back. So if I have a service out there with an API that just gets hit 8 times in pretty rapid fashion, that's a pretty, that you could be putting a lot of load, immediate load on that particular service. But if you simply say, hey, I want, when Twilio makes this callback, I want it to basically hit a service, and all that service does is acknowledges the callback, and then puts the payload of that acknowledgement into a queue. Now you're buffering those 9 hits so that the service you built can decide when to handle those updates on its own. And that is the benefit of the message buffer.
Right.
And that's why I think it's a better way to go compared to just let the service get hammered by like any number of requests. I think it gives you can like sit there and monitor your queue and see how much work is needed, and then decide, ramp up the workers, ramp down the workers, that kind of thing. And I much prefer that than to somehow programmatically queue things in a database or something that allows the server to get hammered relentlessly. I just think I think that's the better way to build an SOA, or to build SOA for the resilience and the unpredictability of requests that come through.
Right. Yeah, that makes a lot of sense, and it confirms what I thought, which is that SOA is really just a term that most of us are familiar with the concepts and use the concepts without calling it SOA.
Yeah.
Aspire EDU, the whole system is built that way. It's built to reach out to the Canvas API to pull in data, and all those requests are going through a message queue, because we got to make a bunch of requests and then write to our database. So, and then we've got other services we have to call along the way. Did we ever call it SOA when we were building it? No.
Yeah.
We talked about using message queues to buffer, as you said, to buffer the load on the database. So that's why, as you were describing, I'm like, I don't know what other ways there are to do it besides using a message queue, and besides just doing it programmatically within your own program. But that's why I said I think the message queue feels like kind of the defining feature.
I mean, and just so that I'm clear, I think in Rails we call them jobs more than messages. Like, messages is what I've come to know it to be.
Sure.
Was here, but I always called it jobs.
Sure.
There was and in Rails there was a database way to do it called delayed job, and it would write, your queue was on your database, Now that would put a load on your database too, but that's how they originally did it. And then they started using Redis as I think is the most common one used now. And then in the Rails world, we use an application or a plugin or a gem called Sidekick, which would monitor the queue and let you do some cool stuff with it. And you could schedule jobs and that kind of thing. Like that's what I mean, I truly did not realize I was doing SOA when I was first started doing Sidekick and jobs and stuff. So yeah, I agree with you. We've been doing it for a while, but I think probably the thing that I feel now is that SOA is getting more hype than it's worth, perhaps, in the startup world. I can understand why a company like Groupon was probably the biggest proponent in Chicago when they switched. They had a Rails app and they decided to break it all up into SOA. And going from monolith to SOA became a really popular thing. But I can say when I talk to startups that are just trying to get a product out to market and they tell me they're doing SOA, I think you'd have no idea what you're doing.
Yeah, you're just using a buzzword at that point because a lot of people are.
Yeah, but no. My point is more, if you are a startup building your first version of your app in an SOA, service-oriented architecture, I think you're doing it wrong.
You mean from the start, you shouldn't be doing it that way?
Yeah, that's my opinion, is that in most cases, unless you can tell me you're going to get dropped on a million jobs to process, SOA is a horrible way to start.
Yeah,
I think monolith is the way to go.
That's probably fair. And is that where, again, could be misstating it, is that a little bit where serverless has come in as well? Is serverless just another flavor of this, and it feels like it is?
Well, yeah, but serverless doesn't have a queue system, though. It does have the ability to get hammered. Like, that's the idea. And maybe that's efficient. And I think actually the requests are queued up on the back end by the serverless people. Like, they're not just, they're creating a message system that you don't see, perhaps. But I don't think serverless and SOA are necessarily the same thing. I mean, I guess I did set up services for us with the Chasms app, but I didn't think of it as, I still thought of it as monolith, even though I guess it wasn't. So maybe it is the same thing.
That's what I'm saying. It's just a different flavor. It's a different implementation. We've done 10 years of message queues, and now serverless is maybe abstracting away the message queue.
Yeah. Hey, there's something there doing that work, buffering those requests, but we don't really have to manage it ourselves. So that might be the easy part of it.
Right.
But I guess my bigger point about the monolith versus SOA at the beginning is, when you start out, you don't have a huge team, and in a way, it's easier to build something where you can see all the services up close, to all the features working together in one code base, versus it truly is a load to be managing 3 or 4 different services. They are their own world. They have their own responsibilities. They basically work at an arm's length from on the other services. And I think it's easier to build an application that doesn't, with a small team of people, that is all working in a single monolith type of environment. Over time, you find out, hey, we're getting a huge load on SMS requests, or we're getting a huge load on this particular feature that we're doing. Let's break that out into a service. Like, I think monolith, and I think starting with a monolith and breaking out services based on metrics and performance is the smarter approach than to follow the buzzword and say, we expect we're going to have 1 million like users from the beginning, and we are going to just go down the SOA path because we'll be there one day. I just don't agree with that approach. I think it's impractical at the beginning, at least.
Right. So what's what challenges are you running across right now with what you're doing?
Well, we're using a different language than I'm used to, so we're using Go. Go is that was based on, I think, more than anything else. It's a compiled language. It strongly typed, maybe overly typed, for what I really think a language needs. It is super fast, but in a queued environment, does that matter? And that's what I don't know. Like, I feel like I don't know that the milliseconds are different when you're doing some work we're doing with email and communications related stuff. I don't know if Go is providing that much of a benefit, to be honest. But in the sense of services, I think you have to do a hell of a lot more architecture around queued environments working together than you do about, hey, you're going to get an email request from a different part of the app, just process it. There's this really you're very isolated, and you have to think about how will a request come in, and then what will this service subscribe to know what work it should do. It's very, very abstract from each other. You're always talking, well, what if this service gets this request from this service? How will it respond? And what are the constraints? And what does that service need? And does this one handle, can this A handle all the needs that service DEF need? Does DEF have the right to request a service in the first place? I feel like it's almost like all these little planets are working together, and it's much harder to get them all to coordinate compared to, hey, this is planet Earth. Let's just focus on what planet Earth needs. Like, that's the complexity, is trying to corral all of the different worlds to satisfy the needs of each other is probably the harder part. It creates a lot more communications, a lot more considerations and negotiations, I guess, between the different services. I don't find it particularly hard. It's just more of like, hey, I'm talking way more about an email service than I ever did before, because all I did before was to say, hey, SendGrid, send this junk out, and that was it.
Right.
And now it's like, all right, what's all the data you're going to request to make this go out? And then what happens when it fails? And then we want to track the status. And it seems like we add a lot more work to each particular feature that otherwise would have been kind of built in and just go. So that's probably what I find to be and then don't even start me on the testing, the end-to-end testing of service integration. Like, that's a whole different thing. You got to manage the message queue, the backend database, the service logic itself. Now you've got to create an end-to-end testing environment where you have to set up messages, check and see if the right behavior, assert the behavior happened. There's so many variations of what could happen. You have to kind of test for all that. So that's a much more complex beast, is the integration testing of SOA, I think.
Sure. And I know, and one more piece is, especially for what we do at Aspire EDU, is we use a cloud provider for the message queue, and if they have issues, then you're at their mercy for the most part, because we've run into that at least once, where the cloud provider we were using for the message queue went down, so that killed all our messages.
Yeah.
So we had to work around that.
Yeah, I mean, it's just the data that you have to track, just like a database. If you lose all
Oh
that,
yeah,
if all those requests disappear, then you've got missing jobs and missing requests. So you have to treat it like a critical part of your system now, that you, like, compared to just a database.
for sure. You said something earlier that I wanted to poke at a little. You said that when you, and this getting a little off of SOA to a small degree. You were talking about Go and about how fast it was. Is it possible that you're not seeing necessarily the speed benefits because the application doesn't need the speed? Like I can see speed benefits for something like a Twitter or a Facebook that's handling, hundreds of thousands or whatever the number is of requests per second, versus your company's, which is probably at a much smaller scale than what a Twitter or a Facebook would be.
Oh yeah, you're totally right. Yeah, I mean, you're right on the money. We don't have that type of load. Now we're building a system for that. So in a way, I think it's a matter of, I'm not aware of predicted load that we are seeing or wanting to see. Like, that's just not what anyone has told me. And I'm really not in a position, or care to be in a position, where I'm arguing, oh, we should get off of Go. Like, this is
Right.
the company chose to go down this path before I even got here. It's not like it's a bad choice. I mean, Go is a very productive language. It's just more of, hey, we've got Rails and we've got JavaScript and now we've got Go. And it's like, do we need a third code base? Do we need that third code base? But if you were to tell me, like, hey, you're going to go into battle for Twitter type of load, oh, hell yeah, I'm not going to go Ruby. I'm not going to go JavaScript. I want something like Elixir or Erlang or Go to, like, handle that kind of, like, to be processing that kind of load. So in a way, this is like for future proofing the services, say.
Sure.
But
Sure.
if you were to say, with our current load, would we see a big difference if we converted these services into Ruby? I'd be like, probably not. But
Right.
that's not. But we're aiming for the future, not for what we were doing now. So I think it's just,
Yeah. And it's not a criticism. It's just a
yeah.
question of, are you seeing the benefits of the speed? And and I think you're right on the money. I'm not sure that the benefits are there. It's more future proofing, and that makes sense to some degree as well.
Yeah, and we still have a lot to learn as a company about how we approach it too. I mean, it's just,
Sure.
this is a new direction for the firm, and in terms of the architecture. And so we're learning things as we go, and it's great. I mean, for me, I've learned a ton, and I would say if I was hired by another firm that was saying, hey, we need to convert, like, we were hitting max production of our current monolith, I have just in 6 months, I've learned a ton about what it takes to have a decent working SOA type of platform. I'd still probably try to talk someone out of it unless they can prove to me they're going to have that kind of load. But
Right.
it's definitely something I've learned, is like, oh, okay, I see how you can do it right and wrong, and what they've learned here. Like, I've been able to talk to people that tried it a certain way and then took a different path. So that's been helpful, for certain.
Sure. Sure. Well, cool. When we were talking about it off the air, I was like, well, let's poke at this a little, because I really don't understand what service-oriented architecture means. I've heard it for years,
Mm-hmm.
and I had a feeling I had a feeling I already knew what it was without it being called that, and I think we came to the conclusion that was right. So
Yeah. So the next thing I need to learn is how to do metrics around it. Like, it's really important to know, like, okay, how fast is it getting jobs done? How fast is it getting requests done? How many are lingering? Do we need to ramp up? Is it inefficient? Is there memory leaks in the process? That kind of thing. So that's probably my next thing, is to work with some folks and find out how, like, I knew how to do that type of profiling in Ruby and Rails and Node, but I don't know how to do it in SOA. So that's a whole different beast to tackle, is the metrics and profiling and stuff.
Sure. Well, cool. I think that covers what we wanted to talk about this week. I don't have anything else for today. You got anything to add?
I think going back, the only thing I'd kind of reinforce is, if you're a CTO at a startup, if you keep hearing about SOA as the great solution solver, that's not the way you need to approach it. You need to first ask, do I have problems that need a service, a dedicated standalone, take a bunch of requests and process them in a separate space? That's what you need to ask. Don't think of SOA as some kind of like grand pie in the sky type of like solution to everything. It's just, I don't think it is that by any means.
It's not the buzzword that solves all your problems. It's just another tool in the toolkit.
Instead of a monolithic problem, you've got 10 different services that are each their own problems. And that's just normal, but it's just a matter of, I would hesitate that anyone in the startup world needs to be worried about SOA immediately. Other than what I was saying, like, if you have an email service, like, I still inherit email platforms as a contractor where I'm like, oh crap, they're directly calling on the like in a synchronous way, they're calling on this external service to do this job, and they're waiting on it to get back to them. That's bad. You need to break this out. Like, like every startup should be doing that type of email platform, communicating like notifications and stuff. But that is not an SOA. That is a feature that has been broken out as a service, but is not putting your entire application through that. That's a very big thing to consider. So that's my last words on it.
Yeah. Something to think about. Well, cool. Thanks for walking us through that, and we'll talk again soon.
Yep. Talk to you later.
Thanks for listening to the CTO Think podcast. Show notes and previous episodes can be found on our website at ctothink.com. Reviews on Apple iTunes are always appreciated and help promote the show. Patreon contributions help us to produce episode transcripts, which allow people that are deaf or hard of hearing to access the show. If you have feedback, ideas, or want to be a guest, please email us at hello@ctothink.com. Show music is Dumpster Dive by Mark Wallach, licensed by premiumbeat.com. Voiceover work by meganvoices.com. You'll hear from us next week.